into this one. So we're given two strings S and P, array of all the start indices of P's anagrams in S. Oh, that wording just confuses me. You may return the answer in any order. Yeah, that's good. So an anagram, it's just formed by rearranging the letters, typically using all the original letters. So I'll go through an example. We'll go through the examples for this one. So an array of all the start indices of P's anagram in S. So I'm guessing what we could do is just get all the anagrams of P and check if they exist in here. That's a naive approach, at least. Anyway, we'll go through the example before I start thinking about that. So the input on S is this big long string and P is ABC. The output is 0 and 6, which means an anagram of P occurs at index 0, and index 6. At index 6 is 0, 1, 2, 3, 4, 5, 6 BAC, which is it. Alright, so actually, do you understand this question? AB is AB, so for this one it occurs pretty much everywhere. Straight away I'm thinking either, I'll go through the constraints first. So the length of S and P can both be between 1 and 3 2 times 10 to the power of 4. And they're all lowercase English letters. I don't think that really matters for the approaches I'm probably going to think of. So my first thoughts off the bat, a super naive approach might be just to construct every, this isn't going to be correct, but I think I'll just write it down so I've just got my thoughts out. Construct every anagram of P, then go to S, or slide the window, S, equal. That would work, but very inefficient. Another way might be sliding window. Immediately sticks in mind, points out to me. I'll have to use that at some point, definitely, I think. Okay, hold on. Window. We could sort, do some sorting, I think. We could sort P, and as we slide through S, sort that substring and random. That sounds like a pretty promising idea to me. What would the complexity of that be? So sorting it is log n immediately, and then sliding a window would be log n. I mean, big O of n. We have to sort it each one, so it would be log n to sort P plus big O of n to iterate over S. But then for every window we want to sort it, so it would be big O of n times another sorting. What do we need? If m is the length of, so this, so it changes. I'll explain what n and m are in a second, but this would equal I hate doing maths with logarithms, they always throw me off. As far as I can tell, is that right? Or I think that's just easier to read it like this. So the time complexity would be n times m log n. So there's an algorithm. That I think it worked. I know there's an algorithm that sort of finds a substring across a larger string and compares them, and I think it works by hashing and using, instead of rehashing the string the whole time. I think this could be completely wrong, but I'm just going to write it down so my thoughts are out, and then if I was on the right track later, I can give myself credit. So there's an algorithm that compares sliding substring, I think. Works by hashing, and instead of rehashing the whole thing every time, I guess, yeah, rehashing the sliding window, using the new, adding the distribution of the new element, and so it's never sliding something that works by hashing, comparing the hash value of the window. Just put this on a new line so it doesn't get cut off by my face. And adding the hash contribution of the new element of the window and removing the old or the removed one just for efficiency. I'm not going to be able to implement that. I don't remember how, and I get stuck. And for this question with anagrams, you'd have to do it. I don't think it would even work, because you'd have to. No, because it's anagrams, so you'd have to do it multiple times, I think, which wouldn't improve anything over my sorting idea. Is there anything better than the sorting idea though? I wonder. Can't really think of one. In the relative view, I might think a bit longer. But I think it's alright. Just LeetCode practice. How would a hash of a window work if characters aren't in the same order? Yeah, that's what I meant about it. Wouldn't work with anagrams. If we were just comparing a substring to the whole string window, we could use it, but since it's anagrams, we'd have to work out the other orders, so I don't think it would work. I think you're right, yeah. I just remember reading that algorithm and I thought, that's impressive if I can remember that, and if it would work here, but it's not. Because I think in an interview, it might be useful to mention something like that. Well, not useful, but valuable to mention something like that. Just could be wrong there. Just to say that you got some extra knowledge. But yeah, I think doing that sorting thing. I'm trying to think if there's any better way to do that. I can't really think of one. I'm not sure if it's going to be good enough strength. I think it might be just alright. So I'll code that one up, the sorting thing first. And if it doesn't work or it's too inefficient, then we'll come back to the drawing board. So yeah, in an interview I like to do the main steps as comments before I even start coding. So just init the, do we need any variables? Maybe just the sizes. Sort p. Oh yeah, the variables include the pointers as well. Slide window over s. Sort window and compare to variables array where the two, if they're equal, add the start index. So add the left pointer value to the result. I don't see why that wouldn't work. And then we'll just return the result. Alright, so I'll just code the simple stuff up first. So we want to initialize our result array, which we can just use a vector. Just call that result. And this is one. Yeah, I can just do it like this. Just our left pointer starts at 0 and our right pointer starts at p.size. I'm not sure if we have to worry about when p is larger than s. Or if that would even mess anything up. I think even when p is larger than s, well, in that case it should output an empty array, which shouldn't be too hard. Yeah, so yep, that should be fine. Is it p.size take 1? Hold on, why can I think? Yes, take 1. Take 1, I believe. I should know that. I should be more confident in that. But we want to sort p first. We don't have to make a copy. We can just sort p. I think this should work. I know that's how you sort a vector. I mean, a string is just an array of characters, so hopefully that would work. Otherwise, we could convert it to a vector first, but then that would be tricky. But I believe that should work. So if we slide the window over s, so we would just do that while r is less than the size of s. Oops. We want to sort the window. Now, how would we sort the window? Should we make a copy? I think we would have to make a copy. So how would we do that? Well, we'll just call it a copy for now. I don't think that's a keyword, a reserved keyword. But the copy you can do by using substring, if I recall, on s, which starts at L, and the length of the substring should just be r take L, I believe. Which I think that's how the substring operation works. So the first parameter is the start, is the index of the, well, I might be getting confused with the erase operation, so I could be wrong there. But I'll continue with this, and then if it is wrong, I can look it up in the documentation. So we want to compare the two. So if copy, we need to do string compare if I recall correctly. Is it like that or is it like that? I don't remember. We just need to sort it first before we do that. So there's definitely some syntax that I'm not super sure about, but I can always look that up afterwards. I just want to get the skeleton of the code done first. So we sort that and then we compare them. I'm not sure if that's how string compare works, but we can look it up later. We'll act like it equals if it returns true if they are equal. But so if they are equal, we will just push back L to the result, and then oops, I messed up my keyboard for a second. Either way, after that we would just increment left and right. far as I can tell, the theory should work. You know, the idea behind it should work. Hopefully the syntax isn't too incorrect. Hopefully even it is correct. Let me see. So let's run that one, just see what happens. String compare. Yep, I don't remember how that works. I might have to look it up. I did, so I must have used it wrong. And matching function. I will have to look it up. See if I can find it on just C++. Look it up there. Okay, so doesn't that work? No matching function. Sorting's a little slow, no. Yeah, I thought maybe, but I couldn't think of anything else at the moment, so I thought I'd implement this and then try and improve it up if we need to. But I thought I can't really think of anything else at the moment. So we'll go down this route for now. Yeah, I was thinking about different approaches maybe after, just so I've got something to show. Maybe, but why is this not working? Look up. Is it not C++? Is it a different thing? Yeah. What seems to be the issue? Does that have to be a pointer? Ooh, I haven't used a pointer in a while. Would that just work? No, I don't remember. I haven't used string compare. You might have been onto something there. The idea is to modify array. We keep the hash value as sum of ASCII values of all characters under modulo of a big prime number for every character of text. We can add the first character of the previous window. The solution looks good is and I thought about something like that, but I thought that might be overcomplicated. So what you're saying is use the create my own, seems goofy for sure. You're saying to keep sort of make my own hash function which produces the sum of ASCII values of each character and then just modulo a big number so it stays small and then compare them. I remember that going through my head. I'm not sure why I didn't stick with it. You say the worst case time complexity is the same. Just reading about it. So good. I'll continue through this one and then I might, if that's the best one, not the best, you know, if that's a good solution, I might try and implement that one too. Why doesn't string compare want to work here? Might be the fastest, but I would rather see code that's easy to follow. Yeah, that makes perfect sense. Let me just do some testing. No, so I've used it wrong again. Is it because it's a string and it's not an actual array of plus with string? Oh, is it, there's an actual compare one. Is same behavior. Try that. So it would be that work? It works, but something is wrong. Oh yeah, what is that? I didn't even check. What does that return? What does that return? Equals, double equals is defined for strings. Can I have just done that the whole time? Does that work? I hope not, because that's super obvious and I thought it didn't work. Let's double check that does work. Why did I think you couldn't do that? Maybe in C or something you can't do that. Let me just double check. Huh? Oh, yeah, obviously that doesn't work. What am I talking about? Okay, yeah. So you're right. Thank you, BetSimp, and also thank you for. I think I've seen you here before. Thank you for popping back in. Only raw character. Thank you. I think I've got some leftover silly knowledge from learning C for a semester at university. That's a lot. You don't want to make that mistake in an interview. That's a bit silly. But thank you. Thank you, BetSimp. If that's how you say your name. Anyway, so what is the issue with this one? Taking an assembly class yet? I did a computer systems class, which should have went from binary to machine through machine code, and then through something, NAND to Tetris, which had a little bit of their assembly code. It's not quite real assembly code. I think it's a simpler version, but that was a bit scary to do. Assembly is something else. I feel bad for the old schools. Yeah, I would hate to have to do that, especially create Roller Coaster Tycoon with that. That's insane. Alright, so I'm guessing this part's wrong. let's just print out what copy is worse than calculus. Calc plus was tough, worse than calculus. Yeah, I can imagine calculus is annoying itself, but assembly sounds like it'd be a lot worse. How's that? Is it RTL plus 1? Yeah, it would be. It would be that. Alright, we have an answer. Let's... Oh, I just press run again. I meant to press submit. I can't see why this wouldn't work. Hopefully it's fast enough there. That's my only issue. Can't think of a faster worst case. Oh no, it took too long. What? It passed the test case. I've never seen that. I've never seen it pass them all but take too long. Oh, that's annoying. Do we have to do the ribbon carp thing then? Oh, that's annoying. It's very annoying. Let me look at that. It's first because of line 15 and 16. Yeah, I'm guessing those sorting it like that and then comparing it is too slow, maybe. Imagine your P is half the length of S. P is half the length of S, then what? Then it becomes bigger of N squared. If S is like N. Ooh. Alright. So I'm guessing I should do what Poopatroo said, which is creating the entire substring on line 14 is not a good idea either. Yeah, I'm not sure. Phone's going off. So I might start. That can also be bigger than if P is half the length of S. Yeah, so not great. I wonder if I can improve this way a bit faster. Ooh, I don't know if I can improve this solution to be possible, or if I should try the ribbon cup. I tried submitting it, so I've got this saved, so I might try doing the ribbon cup. The skeleton of this is fine, so this should this work? Ribbon cup. So much simpler way. Okay, so thank you for telling me that before I torture myself. So there's something I can improve here, apparently. So I'm not sure. I'm still new to Twitch, so I'm not sure how much of the chat you can see. But Poopatroo said you can modify the ribbon carp algorithm so that the hash values is the sum of ASCII values of each thing, so that reordering it wouldn't change anything, which would work, but that's pretty annoying. Yeah, but if you say this way should work, copy pasta, no credit. Well, you still found it and pasted it, so you get some credit. Okay, so you say there's a way most of this code can be improved. Alright, well that's good to know, because that's a very complicated, not very, but that's a pretty complicated approach to a medium. So how can I improve this? In particular for anagrams, only the frequency of the letters matter. So how many values do you actually need to represent a window? Oh, I'm getting stuck. How many values do you need to represent a window? Wouldn't that just be the size and the length of P? You say the frequency of letters. Not sure. I'm guessing you're... What's the word? Implying that I could use the frequency of letters instead of the actual window. 26. So if I make a let me just write my thoughts out so I don't forget them, and hopefully they make more sense. So I could keep track of the current frequency of letters in the window. It's the best. Well, I could just use a vector or something for that, maybe. And just update that as we slide. As well as one, and then as we move the sliding window, just update this vector, and do we just have to compare them or what? I think just compare them. Yeah. Hold on, because do we have to just go through the whole vector, or can we just compare the ones in E? So we'll just do compare them. We can think about that later. So you keep track of the current frequency of letters in the window using a vector. I'm not sure if there's a better way. Or since we know it's going to be 26 elements, we can just use a standard vector. I mean, a standard array, as we know it's a fixed size, as well as one for P. And as we move the sliding window, we just update the vector by removing the letter that we're removing out of the window and updating the letter that we're adding to the window. And then comparing the two vectors. I mean the two arrays. That sounds good to me. We can work out some of the finer details in a moment. So instead of sorting, and hold on, let me just think what would the complexity of that be. Tracking frequency with an array, then that's what I was thinking that BetSimp is hinting to. So I think I might verse a map. Yeah, maybe. Well, since there's only lowercase English letters, I'm not sure. Would a map be better? Maybe. I think a map might be easier to compare them. I'll use a map, I think. Yeah, you don't have to iterate. Oh, we've got conflicting advice. Would prefer an array 26 in an interview. You don't have to iterate of the array. Yeah, that's very costly. What's the trade-off? Yeah, it says like there's only 26. Well, they should both. Oh, okay. So the default memory allocation is worse for them. Because retrieving and setting would be the same, right? If it's constant. And it's just the iterating over them to compare would be what I'm curious about when we compare them. I'll do yeah. I'll do a standard array maybe. Okay, I'll do a standard array and then I'm not clicking on any solutions yet. So we don't need to sort anything. Let's get rid of the wasteful stuff. Yeah. So oh yes, array of integers. I think that's how. So the array for p is 26 long, and then second one, window, we just call it w. It's 26. I've never had my chat so active before. I do appreciate the advice from both sides very definitely. I'll go through this before I start looking at the actual solutions. Yeah, so we do that, and then we want to populate p array. Just for each character p, array would just be c8. Is that? I believe that should work. For some reason I'm really bad at with this stuff, but I think that should work. So if c is a, would update the 0th index. If it's 1, it do it first. Thank you for keeping the discourse civil, at least, everyone. We've got instant access to any value by its key in this array, don't we? I feel like some of this argument will go over my head. Yeah, in the map it's constant time in the average case, isn't it? I'll continue. I'll continue with my coding because yeah, converting the character into its index is just what I did, what I'm doing. Anyway, sliding a window. How do we slide the window? I guess we can make a window at the start first. I'm not sure if this is the best way to do it, but I'll just do it now and then I can clean it up later. What am I? My brain is too distracted. Six your values and array will still be faster than that. That's interesting to know. I don't know. I don't think this is probably not the best way of doing this, but just so it should kind of work. And then what would we do? We would increase each one the first time, and then what we would do is this should work. So I can type the right one we add, and left one we don't. I also have to compare it before. Left one don't. I do like reading through the different sort of ideas. Okay. Anyway, so then we're going to compare it. So what's the best way to compare it? Maybe doing an extra function I can do. And it will just take in both of them. No, that's not how you do it. How do you do that? Yeah, that's true. Work. We can pass it by reference, but it's not changing anything. Actually, anyway, yeah. Cool. Right. Yep. If the element doesn't equal the window doesn't equal that one, false. Otherwise, return should be all good. I'm just trying to think of a fancy way. Could you just do? No, you'd have to do. Very distracting, not gonna lie, but interesting to see all the knowledge. If we compare them, whoops. If they are the same, I understand this code is very messy at the moment. I'll clean it up later just to get a working version. So we do that. Should work, and then we that. I'll run that. I'm just watching. Is that how you do it? I don't remember how you... I've never done this one before. I'm not sure the best way is for that one. I mean, yeah, how to pass an array as a parameter. I might have to look that one up. Yeah, I have to look that one up. Array introduction. Oh, do you need the size? So would that work? No, it cannot be here. Okay, so something is the matter. Probably this one. I feel great about that one. So let's just try. Let's not fight too much in my chat, fellas, when I'm struggling over here by myself. Yeah, I haven't written this very well, but I think this part is messing me up. I used this wrong. Well, what we can do is just everyone's friends here are all learning, especially me. Learning the most, because I don't know very much. So what? Why has that happened? Ah, there, that's right. Is that how? Should that, oops. Should that one work? No. Oh wait, yeah. Oh, I'll just do this for now so it works. To the issue. Oh, wait, yeah. Why didn't that work? I'm a bit confused why this one doesn't want to work. And also, why does it only go to third? Ah, because we returned false. So if we I'm embarrassing myself over here now. Whoa. So this definitely I'm messing something up with updating the window here. So this part might be where I'm messing up. So we so we populate the P array. Let me double check that works. Do we see? Yep, that should always work. Too distracted. I'd rather you keep disagreeing so you don't pay attention to the mess I'm coding at the moment. So populate the first window. Sorry. That should be all fine. Is it I0 or I /? Looks promising there. What's that not caught? It's just print. So what do we get here? Why doesn't it? Oh, it doesn't go through the middle because it messes up. Definitely I'm overcomplicating this one for myself. So we increase the new one, which we just got. Maybe that's the issue. That I'm doing it in the at the wrong time, maybe. it be? That's that one next. Let's just do some print debugging before I embarrass myself. Here. This should give us, for our first example, 111. It does. That one should give us 111. Okay. So now I want to do that after each one, then what? One of those. What do we get? One. And then it should be one. Yeah. No, so it should. Oh, I should print that one up too. So what we start with. It's really bad. So we start with 111, which is correct, and then we have an A, a C, and an E. So where has it gotten the C from? Where has it gotten the C from? What happened? Oh dear. So our first print does that. A, C, E. Why have we got A, C, E? And then after that, with there, you get. So something is terribly wrong. I am stuck. So we want to populate the window of the first array at the start, which works. And then we just want to compare them, whatever. And then we move the window over one. That's why. I'm going to remove the one before it. Now we're into somewhere. Now we're in business. Let's go to print statements. This should hopefully work. No, we're out of bounds somewhere. Or have I done it wrong? Here. Ah, so it's when p is greater. We can just return an empty array then, can't we? If p is ever greater. Maybe. Yeah. Is there anything else I'm missing? Let's just find out by submitting. Yes, we've got a solution. Thank you, BetSimp and Pipuchu for the help, as well as the distracting argument in the background. Just kidding. Nice. Okay, that's a very nice, very cool solution as well. Okay, let me see that one. So you got that too. Oh wait, is that mine? That's mine. Oh, very short and sweet. Sliding window is very important. I don't know where to write it cleanly. Yeah, I've gotten a lot of sliding window ones. It was just the working out how to populate the frequency array for the window at the very start. So, do that. What did you do? So you've got your result vector, you've got your sizes. You only worry about L. You've got your array. No different notation tomorrow. Oh, and they start with zeros. What did I start with? I must not start. No, I didn't start populating mine with a 0, which is. I think about it in terms of loop invariants. Yes, things I have to practice with. I missed the entire solution. Can you start over? No. No. Yeah, array. The annotation is the preferred way. Yeah, that makes more sense. I just have seen that before, so that's what I automatically did in my brain. I'll be sure. Yeah, that's from C. All right. That's good to know. Yeah, that's just a habit that I must have picked up. So use it. Yeah. Well, if using the appropriate array notation is more impressive to an interviewer, then I guess I should use it. So for each character in P at the start, you just populate it. Makes sense. Oh, so this is different. You only have one window. Alright. Your code's a bit too fancy for me to even understand. It's like, I don't know what all of does. Check if the window's all zeros to see if there's a working solution. So if there's an element of a window that's equal to 1, that means that a letter appears one more time in the window than it does in P. And it does in P, I'm guessing. All of it just checks if the provided lambda function returns true for every value it iterates over. All of just checks. Alrighty. Yeah, okay. And what you do is, as you walk through S, tree traversal practice. I'll do a tree question next. Subtract from the window to include a new letter at index R. Alright. It's a bit confusing for me, but that's my fault because I'm a novice. But that looks impressive. and I do appreciate the help as well with the and I can get the main outline of your approach, which is good. I appreciate the advice and the help as well. The different sort of approach, slightly different to what mine is. Mine used a lot of memory to keep 2 arrays, I guess, is my issue. Do this because your code for the loop is always the same. Yeah, so I had to do like initializing stuff where you just have one loop, which is cool. Just implemented a different OK function. Depending on the problem. That makes it basically impossible to get off by 1 errors. Because I'm never messing with the code that deals with the indices. That's true. That's true. Oh, so I get what the OK and the all of stuff does. Only changing what the problem says a good case is. Okay, so all you really change. Okay. It's just coming up with your own way of writing your code to do the same. Ooh, that's scary. I mean, I'll give it a go. I might need a lot of help and a lot of Googling and just copying this, to be honest. But let me see. Oh, that's scary. How do I do that? So I need an OK function, which just, I'm guessing, means it's acceptable. Yeah. It's just all of. Yeah, it's like I'm still so not good at C and C++ that like I don't know what this how that helps and what that means and everything. I know constant means you can't change it, and order means it kind of figures out the type on its own and it's passed by a reference. Get that stuff. Ooh, it's tricky though. I'll give it a quick try and then I'll move on to a another question, but I'll just wrap it. So what can I do? Forgive me if I end up pretty much almost copying that solution and just adding lots of comments, which I might do just so I understand it. I'll just initialize our variables and stuff. We've got our result vector, yeah, which is normal. We have n is the size of s. There's still on a new line, so it's easy for me to read and follow. P, m's the size of p. And l's the left pointer, and you don't do the right, you don't even worry about the right pointer until later. I guess I could do it a bit differently just to add my own thing. And if right equals 0, 2, and I can just have that as a while loop after, I guess. I don't see why not. We also need the window array the proper way, which I'm guessing that 0 means it starts off populated with zeros. I assume. So now we just go through each character in P and just add it to the window. I'll do some clearer indenting so that I can follow it. That's easy for me to follow. Unless I don't know what's better than having the 2 pluses before or after. That's just me not knowing. I like to have it after because I'm used to that. It's probably better in different cases. I know it increments it before it does something, and then it does increments it after it does something. I'm not quite sure. I think it's needed here. Now the function here, I guess we could write that out of it, like in a different function, couldn't we? Would that work, or is that different here? Oh, cool. Okay, just so I know what it means. Now this all of function I would never have thought of because I haven't even heard of it before. And like this part, I'm not even sure what that really means. I guess that's the condition. Yeah, that's the condition. That's really it takes in the current element of the array, I guess, and it returns true if it's 0. Oh, right, we don't need that because I guess that should work if it's in a different function, hopefully. So we go that. Yeah. So we just make my code a bit different, so it's not so pathetic. Or r is less than n, the size of s. Window take a. Decrement that one, and then if r is larger than the size of p, window s at the old L gets decremented, but I think those pluses means after that operation we increment L. I think I could be wrong there, but I think that's what that does. Tell me if I'm wrong, anyone who's here. And that should also be pluses actually. So what have I done? Yeah, and this is where I get a bit lost, so I might go back and add some comments. Yeah. Just wanna push back. Oh. That's a much cleaner solution than what I had already. So if we run that, check. Okay, so maybe I've used this wrong. How would I use it there? What did it say? Oops. That's weird. Okay, so we get stuck somewhere. Maybe it's done like a while thing or like this. Alright, I'll do it in a full loop then. And then I'll do a tree question next, which is scary. I'm just doing the pluses at the end and stuff just to see if that makes a difference. Okay, let me make sure it works for them all. And I'll add some comments. Okay, so yeah, maybe actually, you know, it uses more space to keep track of R up there, so I'll change it. Yeah. Whoops, it's got a bit lost there. So we initialize our variables and stuff. We window array based on P, and then so that slides the window across S. What does this part do? So that part So I get what it does. At the newly added window, the other frequency, S window. I haven't. That sentence doesn't make much sense, but hopefully that's followable. And then yeah, once S is specifying window is the size of size of P or larger. Did Betson believe me? And me as well, hopefully. I think he's been here before. I think he's popped into the stream. I've only streamed twice before this, I think. And he was here once. One day he'll follow. One day he'll follow me. Alright, lost it over the weekend. Once the sliding window is the size of P or larger, then we want the character in decrement the newly added denotes in the window. Since he's gone real world, you would use a map. Usually I do use maps because yeah, then from what I know, they're a lot more flexible and probably maybe easier to build upon. Maybe. Never going to have a constant number of elements in an array that you are searching and index perfectly. Just happens to work out with characters that map to its. I suppose. I think in an interview, that's good knowledge to have there, that you could use an array instead there. But yeah, in the real world, I guess the maps are usually maybe more flexible. I mean, not maybe, I think they are. He was right for this problem. Yeah, I thought he was. Definitely. Let me just add some comments just to say what each thing means. So if I know how this algorithm works, I'm just trying to put it into words. So it goes through P first and it adds one, it just counts the frequency of each letter, and then it goes through S, and each time you see a character, you decrement that frequency in the window array, so that if you get the same characters in the sliding window as in P, then they'll all be zeros. And then once R is greater than or equal to M, that means the window has to remove one from the start. So you'd actually add one to there. I feel like it's a bit anti-intuition, but that should make sense. Right, I'll submit that. I'm fairly happy with that. That's good. I learnt quite a bit. Why is it use so much memory though? Alright, well, time to do a tree question.